Okay, welcome back to your property with exponents chart. You should have the product rule already completed. So be sure you have all of those notes and the fill-in words there in the definition. We're going to move on to the quotient rule. So thinking about the word quotient, do you know what that means? Do you know what operation or what's happening with quotient? That word quotient is the answer to a division problem. So you'll either see the division symbol or you'll see a fraction bar, because a fraction bar also means divide. So to find the quotient of two algebraic expressions with the same base, you're going to keep the base and subtract the exponents. Okay, so let's see what this looks like. So here is the rule, the algebraic rule. So you can see here we have the same base and they're being divided. Okay, we can also set up the same problem with a fraction bar. So we keep the base. The property says if we're dividing and the bases are the same, we keep the base and subtract the exponents. So now instead of variables, let's look at a problem that has actual numbers. So here is 7 to the 4th divided by 7 to the 1st. So this problem has been rewritten with a fraction bar, 7 to the 4th divided by 7 to the 1st. Now the property says when we're finding the quotient of two expressions with the same base, we keep the base, so we keep the 7, and we subtract the exponents. So 4 minus 3 gives us 1. So here's why it works. When we see it expanded, it helps us really understand why it works. So 7 to the 4th power would look like this if we expanded it. 7 times 7 times 7 times 7, 7 to the 4th power, divided by 7 to the 1st power, which is just 1 7. Now, think about regular math. If we had 7 divided by 7, what would that equal? 7 divided by 7 would equal 1. So what we're going to do is cross out a 7 and a 7, because 7 divided by 7 would be equal to 1. And what are we left with? 7 times 7 times 7. We're left with 7 to the 3rd power. So that's why the property works. If we expand it, we see we lose one of those 7s. So let's move over and under the you try, apply the property. Let's try this -2 to the 5th divided by -2 to the 3rd. So let's stack it up and down with a fraction bar. So when the bases are the same and we're dividing, we keep the base and subtract the exponents. So 5 minus 3 equals 2. So why does it work? If we were to expand it, -2 to the 5th power would look like this. And then -2 to the 3rd power would look like this. And then we could go through. Well, -2 divided by -2, that's 1. -2 divided by -2 is 1. -2 divided by -2 is 1. And what are we left with? -2 to the 2nd power, which is what we got with the shortcut or with the rule. Keep the base and subtract the exponents. So now it's your turn to create your own. So in this space right here, create your own example. You could do it with letters if you wanted to. let's see, x to the 5th divided by x to the 2nd. Let's see, so that would be x times x times x times x times x, x to the 2nd. Then I could cancel these out, or x divided by x would be 1. And look at what we're left with. We're left with x to the 3rd. The shortcut, keep the base, subtract the exponents. Okay, so create your own there if you want to do variables like I did, or come up with another base. And then moving to the last column, this is where it gets a little more challenging. We have examples with coefficients. So the coefficients, again, those are the numbers that are out front. So in this example, 45 is a coefficient, and so is 9. Okay, so if we wanted to expand this, this would be a to the 3rd and b to the 2nd over 9ab. And then to simplify it, an a divided by a would be 1, and a b divided by b would be 1. So you can see we're left with a to the 2nd and b. And then the coefficients, like the problem above, coefficients, you do your regular math or your regular operation with those, because these are not the same base. We have a 45 and a 9. So now we just do the math. What is 45 divided by 9? And that is 5. So this would be our final answer. Okay, now I showed you expanding, but let's do it with the shortcut. Okay, so we did regular math here, 45 divided by 9, which gave us 5. And now the a's are the same, so we keep the base and subtract the exponents. Now, do you see how the a doesn't have an exponent, but there's one a? We're allowed to put a 1 there. Okay, so 3 minus 1 is 2, so that would be a to the 2nd power. And then b to the 2nd minus b, that's also b to the 1st. So b, and 2 minus 1 is 1. Now, I didn't write a 1 here, but you can. It's like optional. So a b or a b to the 1st, those mean the same thing. All right, so our quotient rule is a little bit similar to our product rule, except when the bases are the same, in your dividing, you keep the base and subtract the exponents. Okay, so now you should have all of this filled in, and we're going to do some practice with the quotient rule.